It's a pleasure to be here with good friends and, well, actually good old friends and good new friends as well. So thank you very much for being here today. I'm gonna follow up with Kent. So as Kent was explaining, after the decarbonization of the electric grid and after the electrification of the vehicle fleet, we will reduce the environmental impact of the people living and working in Kendall Square from 17.19 tons of CO2 to 15.50 tons of CO2. From this, 1/3 is related to buildings and construction process. Okay, and when we talk about CO2 and when we talk about buildings and construction, we have to make difference. There are operational CO2, that's the CO2 that we produce with all the lighting and air conditioning. And there is the embodied CO2 in the materials of the building. And so let's look a little bit on the materials. As an example, if we look into the sector of iron, steel, and cement, it produces 9% of the global CO2 of the planet. Just to give some context, India, the country India, produces 7%. So what we are saying here is that 1.38 billion people produce less CO2 than the steel, iron, and cement sector. Another thing, how are we calculating the CO2 per person? What we are doing is we are taking all the CO2 that each country is producing, and we divide it by the people in the country. With that lenses, countries like United States and China, they are the bigger offenders in the planet. But, okay, so let's look this with a different lenses. As Ken was explaining, what if we look into how the goods and products are moving into the world? Okay, if we look with that lenses, we will see that a lot of the CO2 that China is producing is being exported to other countries in the form of vehicles, telephones, computers, materials, and the final life of these products are happening in a different country. So we have to attach that CO2 to that country. With that lenses, countries like China, they became almost negative CO2 producers. Food for thoughts. Is that the reason why we are starting to do this research and we are trying to understand the impact, the environmental impact of people living and working in Kendall Square? We are using the lenses of the consumer carbon footprint, a little bit what Ken was explaining before. Each of our actions has CO2 attached to that action, okay? Operational and embodied. So, yeah, a little bit of awareness. And also, each of us, we have a different carbon footprint. In order to have that bubble over there, that indicator, we are using life cycle assessment methodologies to unify all this carbon footprint in one indicator. But yes, each of us, we have a different carbon footprint depending on where do we live, how do we move, or even what do we eat. The team, we are gonna go through that. But let me keep focus on buildings and mostly on existing buildings. Let's talk about the operational CO2. Usually we say that a building has 75 years of lifespan, and from that, what we are doing is we are taking all the energy that we are producing during that life and making the calculation into CO2, okay? That's what we call operational CO2. So how can we reduce this operational CO2? There are 3 ways. One is changing our behavior. The second is more efficient technologies. That's what we usually call building retrofitting. The third one is increasing the thermal isolation. That's deep building retrofitting. Let's start with the first one. And we can use, let's use hybrid work as a good example of how are we changing our behavior through hybrid work. People are saying that hybrid work will reshape the cities. Offices are going to be empty. The city is going to be empty, like this movie. Everything is going to be empty. I don't think so. Telework has been here since the 80s, and we are learning a lot from teleworking, okay, from working from home. What we are learning is that people working from home, usually they are a little bit more efficient than people working at the office. But the problem is that these people, they are less likely growing in the company. Why? One of the reasons is the lack of trust. Yeah, we are still being animals. I'm so sorry, humans, we are a little bit animals. And we build trust with this thing that is happening here, face-to-face communication. So that's one of the reasons why we are kind of, at least in the United States, looks like we are coming back to normal after the pandemic. And we have numbers very similar to 2019, when we used to work from home between 1 and 3 days per week. Okay, let's take that number, 3 days per week. And so let's have a policy, imagine this policy in Kendall Square, where everybody living and working in Kendall, they spend 3 days working from home. That will reduce the CO2 from commuting. It will reduce the operational CO2 at the office, but it will increase the operational CO2 at home. So the final balance of this is that we can reduce 0.05 tons of CO2 per person living and working in Kendall Square per year. And we are not going to have a significant socio and economical impact. So let's go to the second kind of measure. So what about more efficient technologies? What if we have more efficient electric pumps? What if we have more efficient ventilation and air conditioning? What if we have more efficient lighting? And of course, we will need like a super smart building to control all these new super efficient things, because I cannot control for sure by myself. Okay, so what we are going to do here is we are going to reduce the operational CO2, but we are going to increase the embodied CO2 because we are bringing more stuff in the building, more things into the building. So the final balance of this is that we can reduce up to 0.40 tons of CO2 per person per year in Kendall Square. And we will have a small socioeconomical impact because we are going to bring some specialized jobs into the community. That's good. Let's move into the third option. The third option is deep building retrofitting. So what if we increase the thermal isolation of our buildings? What if we improve the exterior cladding? And what if we improve the air tightness? Same thing. For sure, we will reduce the operational CO2, but we are bringing more materials in the building, so we are increasing the embodied CO2. The final balance of this is we can reduce up to 0.65 tons of CO2 of each person living and working in Kendall Square per year. And we are going to have a significant impact into the socioeconomical indicators because we are bringing jobs into the construction sector. Okay, now is the challenge. How can we reduce the embodied CO2 of existing buildings? That's kind of like a heck of a question. So just let's think about this, because what we are talking here is every time that we extract a material from the nature, we send it to the factory and we build the construction material. Then we send it to the construction site and we build the building. And that material spends 75 years in a building, and then we discard or we reuse the material. All that process has a lot of embedded CO2. And what we do is we divide all that CO2 in the 75 years of the building. So if that CO2 is already embedded there, how can we reduce it? There is not a very good solutions, but there is one that is just by expanding the life of the building. So in a step of removing the building, we could reuse part of the building. Usually we can reuse between 40 and 60% of the building and expand the life of the building. Of course, we are going to bring new materials to the building, so that materials, they should be sustainable and probably local production. And maybe we can also explore other options of carbon sequestration materials. Let's look a little bit very quickly into this. Expanding the life of a building. Some research says that we can eliminate up to 20% of the environmental impacts of the building. Also, by just using local materials, we can reduce up to 20% of the embodied energy, embodied CO2, sorry, that is in the material due to the transportation. And what about carbon sequestration? Well, carbon sequestration materials, they are not new, but they are kind of new for construction. And to be honest, I have no data. I don't know the life cycle of these guys. So probably you're saying, well, why Luis is talking about this if he has no data? Yeah, okay, true. But it's a good safe, it's a good entry point, because I think that materials, in the step of being a problem, maybe they can start being a solution. So what if, in the step of talking about steel, iron, and cement, we start talking about biocomposite building materials, fungal mycelium, algae, maybe materials that they can capture CO2, but maybe they can also produce oxygen. What if we can plant a seed and grow a house? What if we could live inside of a live house? Okay. We are at MIT, and maybe I am going too far, but I just throw the concept. Let's see what happened. Let's go back and wrap up. Okay, if we just take the hybrid work, building retrofitting, and deep building retrofitting, we put it together, we can reduce up to 1.20 tons of CO2 per person living and working in Kendall Square per year. Now, I'm going to give the mic to Roland Dolly, and let's see how life work symmetry can reduce that bubble over there. Okay, thank you very much. Muchas gracias.